start now.
In this session we are going to discuss about introduction to heuristics. This session is designed to discuss about what is a heuristic function, what are the different types of heuristic functions we use, where we use these heuristics, what are the different types of heuristic functions also we will discuss. So by end of heuristic function you will be able to understand what is a heuristic function, when can we use a heuristic function in a search algorithm in artificial intelligence. So these heuristic functions are in the form where the additional knowledge of the problem is used in search algorithm in solving a problem using artificial intelligence. So when we are going to find out a goal for a given problem within the feasible amount of time, if you want to solve the problem, then we use heuristic function. So heuristic function always will try to find the rapid solution with a limited amount of accuracy rather than giving a perfect solution. So if in general when you are solving a problem, if it is not possible to solve the problem by step approach in either in artificial intelligence or machine learning algorithms, we use heuristics, heuristic values or heuristics. So these will be the combination of accuracy versus rapid finding of a solution. Then what that is a heuristic function. Then what is heuristic function? So this heuristic function, we will try to find out a particular value for every state of the problem using a particular function. We use that value in order to choose our next state in solving the problem. So these will be considered as, this heuristic function or the heuristic value can be considered as a means of trading between accuracy and speed. So if you want to find out the solution in a rapid way, we keep a particular amount of accuracy, particular boundary for the accuracy, and we'll concentrate on the speed of the solution. So in that case we are going to use a heuristic function. This heuristic function always will try to determine how near a state to the desired state. That means how near our state which you are going to select to the goal state. So that is a work of heuristic function, and this heuristic function is not fixed. These are going to change from a problem to problem that you solve, or particular challenge you are going to solve, and you can define your own heuristic function in order to get the solution to the given problem. As we are telling that these heuristic functions always try to find the rapid solution rather than concentrating on the accuracy. If you want to get the accurate results also, we can combine heuristic functions with the optimized solution, so that we'll get the optimized solution as well as in a faster manner. So that is the use of the heuristic function. When you are solving problems using artificial intelligence techniques, we need a large amount of data, and there will be so many constraints on that data, and there are number of tasks given to find the goal state. So with this kind of information, if only particular type of technique is used to find a solution, it may not be possible. So we go for heuristic functions. By applying all the constraints and on the given data, then we go for heuristic functions. So when you are using this heuristic function on a particular search problem or any problem in AI, we can completely reduce the complexity of the problem, complexity of the given problem, right? And how much complexity you will reduce, it depends upon the quality of the heuristic function you decide to use in that problem. If you find out a good or optimized or heuristic function, definitely the complexity can be reduced to the very minimum kind of solution, right? So that is about the proper use of heuristic function. And when you are using these heuristic algorithms in AI, in different search algorithms, this heuristic function will have certain properties. then those search algorithms using heuristic will have certain properties, and those properties are admissible condition, completeness, dominance property, and optimality property. So when the algorithm you are implementing using a heuristic search, if it gives the optimal result, then it is known as admissible condition. So if you design a heuristic function so that it gives the optimal solution, then the search then we say that that search algorithm satisfies the admissible condition. And when you are using a heuristic function in a search algorithm and the algorithm is going to find out a solution, then we said that the algorithm is complete. And coming to dominance property, if there are we are using two different algorithms, A1 and A2, which makes use of heuristic search, right? So if these algorithms, when A1 will dominate A2 if the heuristic value or the heuristic function h1 of A1 is dominant or superior to the h2 of another algorithm A2, then we say that A1 will dominate A2, and it should satisfy for all the nodes of the, that means all the states of the algorithm that you are using, or all the states of the problem. So then A1 is going to dominate A2. So when we are using two, I am explaining about it. A1 and A2 are two algorithms which makes use of heuristic functions, and when you are using heuristic functions, the heuristic value h1 of algorithm A1 is superior than the heuristic value h2 of A2, then we say that A1 dominates A2. And one more thing to remember is it should satisfy the dominance, that superiority should be satisfied for each and every node or state of a problem. And coming to optimality property, if algorithm is thorough, allowable and dominates other algorithms, then it is optimality. That means we say that the algorithm which is using heuristic function is optimal. So whenever we are using heuristic functions, these heuristic values are used in each and every node or state of the problem, and we will try to get the rapid solution. And if we combine optimality principle also, we may be, along with the fast solution, we also get the accurate solution. In that case, if it produces optimal result, it is admissible condition. If one heuristic value of algorithm dominates or superior than the heuristic value of the other algorithm, it satisfies dominance property. And if the algorithm in any situation it gives the solution, it is said to be complete algorithm. And if it satisfies all the above properties, then the algorithm which is using particular heuristic function is said to be optimal heuristic search algorithm. So these are all the properties of heuristic search algorithm, but not heuristic function. When we are using heuristic function in algorithm, then algorithm satisfies all these properties. And there are different types of heuristic search techniques. They are categorized into direct heuristic search technique and indirect or weak heuristic search techniques. Generally speaking, when we divide the algorithms which solves the search problems in AI into informed search algorithms and uninformed search algorithms, whereas in uninformed search algorithms we follow a particular blind strategy to traverse the state space or search space in order to get the solution. In generally, many authors will not call that search algorithms as heuristic search techniques, but some authors will also call those informed search techniques also as a direct heuristic search techniques. These can also be told as blind control strategy, because we will not manipulate or add any other kind of information in this search. We simply follow either one particular blind control strategy. Like for example, if we take breadth first search or depth first search, in depth first search we always go depth wise, whatever the situation may be in the complete search space.